In the applications of linear functions, you're going to learn how to apply a new form to write the equation of a line, and that is called the point-slope form. The point-slope form tells us that we can get the equation of a line if we know a point x1, y1, and a slope m. Then the point-slope form is y minus y sub 1 equals m times x minus x sub 1. Now that comes from the slope formula, but more information will be discussed in that in the college algebra section that pertains to this topic. Right now, what I want you to be able to do is to, given that form, write that equation in the slope-intercept form. So that is to go from this form to the form y equals mx plus b. Example 1 gives us some equations that are in the point-slope form. Now we will want to simplify those to put it in the slope-intercept form. The first one is y minus negative 6 equals 3 times x minus 4. I just want you thinking about this. I don't expect you right now to understand all of it, but look where x1 and y1 is in this point-slope form. The x1 and the y1 in this example 1a represents our ordered pair 4, negative 6, and the slope is 3. This equation therefore represents the equation of the line through 4, negative 6 with slope 3. So this equation in slope-intercept form is y plus 6 equals 3x minus 12. Then we subtract 6 from each side to get y equals 3x minus 18. In example 1b, we have the equation y minus 5 equals negative 2 times x minus negative 1. Notice the placement of the x1 and the y1 and the value of m. This really represents the equation of the line through negative 1, 5 with slope negative 2. Our goal right now is just to simplify this and solve it for y. Simplifying the right side inside parentheses, we get y minus 5 equals negative 2 times x plus 1. Now we distribute on the right to get y minus 5 equals negative 2x minus 2. The last step is to add 5 to each side. So we get y equals negative 2x plus 3. The last example of this type is y minus negative 3 equals 3 halves x minus 4. There are two ways to do this problem because of the fraction. So let me show you both of those ways and you can choose which way you prefer. I'm first going to simplify the left side to get y plus 3 equals 3 halves x minus, distributing on the right also, 3 halves times 4. 2 goes into 4. 2 times, and 3 times 2 is 6. So then we can subtract 3 from each side to get y is equal to 3 halves x minus 9. Now an alternate approach is to clear the fractions. And so if we clear the fractions, let's look at this equation as y plus 3 equals 3 halves times x minus 4. The least common denominator is 2. And so what we would want to first do is multiply each side by the 2. This gives us 2y plus 6 equals, well, the 2 times 3 halves. The 2's divide out, and we're left with 3 times x minus 4. So that's 3x minus 12. Understand that I do not distribute the 2 inside the x minus 4 because this is a product of 3 halves times x minus 4, not a sum. I'm then going to subtract 6 from each side to get 2y equals 3x minus 18. Now to solve for y, we divide each side by 2. And that gives us y is equal to 3 halves x minus 9. So you see the same equation results. And really what I use to determine if I need to clear fractions or not is if the fraction goes into the constant term inside parentheses. That is, if the denominator divides this constant term, then I won't clear the fractions. But if I had, for instance, a 5 there and the 5 did not divide into the 4, then I would clear the fractions from that equation.